We are now moving on to our very last lesson on binomial expansion. And basically what we're doing today is we are going to take that binomial expansion and we're going to multiply it by another binomial. Yippee. So things are going to get a little bit more complicated as we're trying to find that specific term that we're looking for. So it tests a little bit of your logical reasoning to be able to figure out the process that takes place. So let's get started on this. The first example says to find the x to the third term in the expansion of 3x plus 4 times x minus 2 to the fourth power. Now I'm going to illustrate what it's actually asking for. This is not the way that I would expect you to show your work because it takes a longer time to do this. But maybe you've seen the box method for multiplying polynomials. If you have, I'm going to draw a lot of boxes here. And what we're doing is we're taking this polynomial, 3x plus 4, and we're multiplying it by this entire expansion, x minus 2 to the fourth. And I've already cheated and I've already figured out what this is. And it becomes x to the fourth minus 8x cubed plus 24x squared minus 32x and plus 16. So we would be taking this binomial, 3x plus 4, and we'd be multiplying it by this entire polynomial if that were expanded out. And what we're trying to find is the x to the third term. We're trying to find the one that has x cubed on it. So if you were to multiply right here, you'd take 3x times x to the fourth, and you'd get an x to the fifth term. That's not the one that we're looking for. I'm going to cross that one out. This one would give you x to the fourth, but this one here would give you an x to the third because x times x squared gives you x to the third. That's a good one. This would give you x squared. This would give you x. If you go on the bottom row, 4 times x to the fourth would give you x to the fourth. That doesn't work. But this one, you'll notice, would give you the x to the third. And then all of these do not give you x to the third. So really what we're trying to do is we're trying to find this term, and we're trying to find this term, and at the end, you would just combine the like terms together. We would end up adding those two terms together. So instead of doing it this long way, where we'd have to find this entire polynomial up here, let's go ahead and do it a little bit shorter way and use our reasoning skills. So what we're doing is we are going to be taking 3x. So I'm going to start with 3x. And I know that 3x has a power of 1. So what I have to do here is I have to take that 3x and I have to multiply it by the thing that has a power of 2, because x to the first times x to the second power would give you x to the third. So from my x minus 2 to the fourth, I want to find the one that has a power of 2 on it. So I'm going to have 4 choose something. I'll figure that out in a second. We had our first term is x. I'll figure out the exponent there in a second. And we had negative 2 is our second term. And since I know that this binomial expansion, I want the power of 2, I'm going to put a 2 right there. And if that's a 2, the one over here is a 2. And since this one's a 2, this will also become a 2. So hopefully you see that if I were to multiply all of this out, it would result in an x to the third term. Hopefully that makes sense. Now what we're going to do is we also have another combination that could take place. This 4 here, we could take this 4, and in order to make that an x cubed, we would have to multiply that by the x cubed term from over here. So let's set up our binomial expansion. Now in order to make this one an x cubed, this would have to be a 3. And if that's a 3, then this is a 1. And if that's a 1, then this is a 1. So basically what we're doing is we were finding those two terms when I did it the long way and I drew those boxes out. we're finding those two terms, and then at the end, we'll have to add them together. So let's start with this first one. We have 3x, just leave it as 3x, times 4 choose 2. If you take 4 choose 2, that is equal to a 6, times x squared, that's just x squared, and times negative 2 squared, that is a 4. So if you were to multiply all of that out, 3x times 6 times x squared times 4, that gives you 72x cubed. Now we're going to go on to the next one. We start with the 4, and we have 4 choose 1, that equals a 4, times x cubed, that's an x cubed, and negative 2 to the first is a negative 2. And if I multiply all of these together, 4 times negative 2, that's a negative 32x cubed. And at the very, very end, what we'd end up doing is we'd combine the like terms together. So if we combine this one and this one together, you just add them together, and you end up with 40x cubed. And that becomes your final answer. So kind of a long process, and it tests your ability to kind of reason through and figure out all the possibilities that could take place. So go ahead and try the next one on your own. You're going to pause the video here. Make sure you understand this one because it's going to get a tiny bit more complicated after this. So go ahead and hit pause. Okay, if you were stuck, I showed you how to set this one up on your own. You were taking that x term, and in order to make it x to the 5th, we needed another x to the 4th. So x times x to the 4th would give you x to the 5th. And now the 7 has no variables on it, so we need this one to be x to the 5th. And then evaluate those, combine them, and you should get the right answer. Let's move on to the next example. It says, find the x term in the expansion of this whole mess here. So I'm going to start with the very first term. I'm going to start with this 1. Now that doesn't have any variables on it. So if I take that 1 and I multiply it by some term from over here, in order to make it the x term, I need the x term from over here. So let's go ahead and do 3 choose something. And we have 5x, and we have negative 3. So you'll notice that 1 did not have any variables on it. So in order for the x term, I just need this to be x to the 1st. We put a 1 there. This becomes a 2. And if that's a 2, then this is a 2. So I know that when I multiply all of this out, it would become x to the 1st, which is just an x. Now let's go and find the other possibility. We're going to use this 1 over x squared. So now you have to think, since this is 1 over x squared, in order to make it the x term, I would need to see an x cubed on the top. And then 2 of the x's cancel. It results in just an x on top. So what I need to do is I need to take this binomial expansion and I need to find the x cubed term. So let's go ahead and do that. We have 3 choose something. We have 5x and negative 3. Now in order to make the x to the 3rd term, I'm going to put a 3 up here. If this is a 3, then this is a 0, and that also becomes a 0. So if I simplify both of these, they're going to give me the x term, the x to the 1st term. So let's go ahead and simplify them. For the first one, you have 1. We have 3 choose 2 is 3. 5x to the 1st is 5x. And negative 3 squared is a 9. And if you multiply all of this out, 1 times 3 times 5x times 9, that gives you 135x. And if we take the next combination, we have 1 over x squared times 3 choose 0 is just 1. Then we have 5x being cubed, so that's going to be 125x cubed. And negative 3 to the 0 is 1. So you'll notice a lot of 1's being multiplied here. 1 times 1 times 1. That makes it easy. And this, if you add this together, becomes 125x because the x cubed and x squared, a couple of them cancel out, and you're just left with an x on top. So finally, at the very end, these are our two terms that result in an x to the first. We can just add them together, and we end up with 260x. So that would be our x to the first term at the very end. Moving on, we have one more example. It says to consider the expansion of x squared times this messy thing, and it says that the constant term, when all is said and done, will be 16,128. So we know that that first one is x squared, and it's going to distribute to some term over here. You can't distribute yet, order of operations. You have to do the binomial expansion first. But when we take x squared, if you were to multiply it by something over x squared, and then all those variables are going to disappear. They're going to be gone. So what I have to do is I have to take this binomial expansion and I have to find the one that would result in an x squared on the bottom. So let's go ahead and do that. So it's row 8. We're going to do 8, choose some number. We have 3x squared, and we have k over x. So for this binomial expansion, I need the one that results in an x squared on the bottom. So let's go ahead and maybe take a guess here. We could try a 3 here and a 5 here. And if you tried 3 and 5, you'd have x to the 6th on the top, and you'd have over x to the 5th on the bottom. That wouldn't work. It results in more x's on top than on bottom. So it's not going to be 3 and 5. Let's try a different combination. Let's go ahead and try 2 and 6. If I try 2 and 6, then I'm going to have an x to the 4th on top, and I'm going to multiply it by an x to the 6th on the bottom, and you can see that that will result in x squared on the bottom. So that's the combination that we want. And so if this is a 6, we're going to put a 6 there. So now let's just go ahead and multiply it all out. We have x squared times 8 choose 6 becomes 28. 3x squared being squared gives you 9x to the 4th. And then this would be k to the 6th over x to the 6th. And if you multiply all of that together, it should equal the constant term of 16,128. Now hopefully you notice the x squared times x to the 4th, that would give you x to the 6th. But if you divide it by x to the 6th, they all just cancel out. So we're going to take 28 and multiply it by 9, and that gives us, I'll move over this way, 252 k to the 6th equals 16,128. If we want to solve for k, we can divide by 252. They go away, and we're left with k to the 6th is equal to 64. And hopefully you remember from the other videos, to get rid of that 6th power, just raise it to the 1/6 power. And 64 to the 1/6 power is, oh, such imaginative answers here. K equals 2. So there is your final value of k. There's one more to do on your own. This one's a teeny tiny bit different than the last one, but go ahead and give it a shot and see how you do. And pause the video here. I'll give you kind of a hint at the very end when you unpause it. So go ahead and hit pause. Hopefully you got this far. Hopefully you found the two different ways that you could make x cubed, and you saw 4x cubed and 6cx cubed. When you combine them together, 4x cubed plus 6cx cubed, when you combine the like terms, it should equal 22x cubed. So what we're going to do is we're going to subtract 4x cubed from both sides, and we're left with 18x cubed. And finally, 6 times what number gives you 18? Well, that number is 3. So C equals 3 on that one. Kind of rushed it.